Homework Solutions 1.13. Design a two-wire DC distribution system to provide electric power at 120 volts to a load consisting of 500 and 150 ohm loads connected in parallel. Assuming the distribution cable has a total equivalent resistance of 3 ohms, what's the efficiency of the system? So what they're saying is, given a supply voltage that connects to a load through a 3 ohm cable, and then supplies a load at 120 volts, determine the efficiency of this system right here. And so we're asked to find the efficiency. The solution is that we can determine the power delivered to the load and the power delivered by the source simply by knowing the current in the system. To do that, we'll just solve for RL. There are 500 resistors, each having a load of, or a value of 150 ohms. So that says that RL is equal to 500 over, sorry, it's 150 over 500. So the total resistance of this Thevenin circuit is 0.3 ohms. The mesh current, therefore, is going to be I is equal to 120 volts divided by 0.3 ohms, gives you 400 amps of current flow. I can determine the voltage drop across this resistor just by multiplying 400 amps times 3 ohms gives me 1200 volt drop, a huge voltage drop. That means the supply voltage has to be V3 ohms plus 120 volts, and that's 1320 volts right there for the supply voltage, so quite high. I can determine the power delivered to the load as the load current times the load voltage. That's 48 kilowatts. And then the power delivered by the source is going to be the source current, 400 amps, times the voltage, which we just determined to be 1320 volts there. So that's going to give me 528 kilowatts. The efficiency of this system is then equal to 48 over 528. Multiply that by 100% to convert it into efficiency. Get a pretty low number of 9.1% efficient for this answer.